So hopefully you worked through this example prior to looking at the video, and we can see whether you were correct with it or if you made any errors where you might have made those. The Highway Administration shows that in a study of 14 random cars on I-95, they had an average speed of 73 miles per hour, standard deviation of 5. We had a study of 20 randomly selected cars on I-83, showed an average speed of 69.5 miles per hour, standard deviation of 4. Again, the most important line in this entire hypothesis test is that the two populations are normally distributed and the standard deviations are unknown but equal. Okay, so again, that's what you're looking for when you're doing these types of hypothesis tests. Is there evidence to suggest that the average speed on the two highways is not the same? We're going to test at the 1% significance level. We would assume that if there's no real difference in the posting of the highways and the speed, etc., that the null hypothesis would be that the average speeds are the same. The alternative hypothesis, obviously, it says that they are not the same, so x bar 1 is not equal to x bar 2. And just like we did before, we're going to define the groups. So the first group, let's just call that the I-95 speeds. And the second group, let's call that the I-83 speeds. So next what we're going to do is we're going to collect up some variables from the two groups. Group 1 we know is the I-95. And we know that the average speed on I-95 was 73 miles per hour. The standard deviation was 5 miles per hour of that group, and the sample size was 14. In the I-83 group, the average speed was 69.5. The sample standard deviation of that group was 4 miles per hour, and the sample size for this one was going to be 20. The significance level is going to be 1%. Now notice that because it's a two-tailed test, we have to split the alpha level. So alpha over 2 is 0.005. And that's the value that we're going to utilize to look up the critical t. Now we're going to go to the t distribution. We're going to look up critical t. T critical, the alpha over 2 is going to be 0.005 that we use. And then the degrees of freedom are going to be 14 plus 20 minus 2. That should be 32. So we go into the table. We're going to go to 0.005. And then we're going to go down to 32. It just so happens 32 is in there. And it's 2.738. So our T critical should be 2.738. And that's the value that we're going to plot on both sides of the distribution. All right, so if we were to construct our distribution as a two-tailed test, we have a left tail, we have a right tail, we have negative 2.738, and we have positive 2.738. And then the range of values for any t distribution that we use, negative to positive infinity, 0 is immediately in the middle. Now we're going to go ahead and be able to compute the test value for this. Okay, so this is where it gets a little bit tough. First, we're going to start with the S sub p. We're going to subtract 1 from the first sample size, so that's 13. All right, so that's going to be 14 minus 1 times 5 squared plus, remember N2 was 20, so that's going to be 19 times 4 squared, and then we're going to divide that by 32, which is N1 plus N2 minus 2. All right, so again, just substitute back in from these 4 values to be able to find what S sub p is. Right. Now remember, we're going to start by figuring out the numerator. Okay, so don't worry about the denominator yet, just figure out that first part. So we're going to throw that in the calculator. This one's much more tame than the previous one. and I end up with 629. So our S sub p is the square root of 629 divided by 32, all under the radical. And if we get that correctly, I end up with 4.434. Now we're going to find the estimator of the standard deviation. That's our S sub x bar 1 minus x bar 2. Remember, we take the previous answer, the S sub p, and we're going to multiply that by the square root of 1 over n1, which was 14, plus 1 over n2, which is 20. If you have trouble inputting that into your calculator, look at the previous video, and that'll show you the syntax. I end up with 1.545 as the estimator. And then finally, the test value, we take the difference in the means. So remember the difference in the means, we had 73, I believe. So we have 73, we have 69.5, and then we have that 1.545. So 73 minus 69.5 divided by 1.545. Again, just like any test value, make sure you put the difference in parentheses. And we end up with 2.265. That's our test value. Right. So the last thing we're going to do is we're going to go back up. We're going to plot that on the distribution. And we see that 2.265 falls pretty far outside of the reject region. So maybe maybe right about here. All right, it's not really that close, not all that far away either. So 2.265. And that means we get, once again, a fail to reject. Okay, so we're going to go back up. We're just going to copy down the question. And we're just going to say that since we fall in the fail to reject region, so since the test value falls in the fail to reject region, there is not evidence to suggest that the average speed on the two highways is not the same. Right. So in the next examples, what we're going to do is we're going to take a look at what happens if the population standard deviations are unknown and unequal.